everyone. My name is Drew. I'm a staff engineer over at Reddit, specifically on the Android platform team. And today I'm here to talk to you about building Android Studio plugins and how to kind of use them to level up your developer experience. First, though, I kind of want to get into talking a little bit about the developer experience, especially as a team or organization starts to scale. So as a company grows, their need for more and more developers will grow, and logically their code base will just start to grow. Product will introduce more and more features and changes and more developers to work on it, and more code gets pushed into these repositories. Naturally, the way a code base may have approached this product in the early stages of the company, and development may not keep up with the needs of the team as it scales. This makes sense, right? In the early stages of a company, when it's young, you may not want to put the cart before the horse and invest the time and development to build up for 20 million users when you may not even get the one. So thus, when we do scale, we start to introduce new patterns in a more thoughtful way now that we can afford the investment of scale that our code bases may desperately need now. So just as the code base evolves, we need to evolve how we work within it. Building out tooling can go a long way to accelerating this change at scale, but it is often not the only thing that scaling needs. Documentation, policy, and process improvements are also important to how we scale. So as we introduce new patterns and try as we might, legacy patterns don't just go away, no matter how much we wish they would. So when we introduce new patterns, we need to be careful and attentive, or our code bases can grow into a convoluted mess of old and new patterns. Just to insert that one XKCD comic about standards. So without better tools, policy, and processes, it's easier for developers to kind of reach what's familiar, what is familiar and just works, and not really a centralized way forward. So when asking our teams to migrate over to the new hotness, providing just manual migrations can be a daunting ask, and can also be error-prone to introducing shiny new tech debt. Even with new patterns, the boilerplate involved can lead others to reach for copying and pasting existing or new examples, which can risk additional tech debt growth. So it's also important to think carefully about the tooling you build, as it's easy to kind of collect a grab bag of loosely understood scripts that kind of fail to scale to meet your new solutions. Now, often losing context in which your developers need it most and where they're working. So just as we thoughtfully approach the solutions to our products, we should put the same level of care into our tooling. When it can be tempting to treat everything like a nail, a hammer isn't the solution for everything. So with that, let me segue into a very shiny hammer. Got it. And so that gets to the meat of this, is to talk about the IntelliJ Platform SDK, which is the toolkit for extending Android Studio and all other IntelliJ-based IDEs. But before we kind of get into the SDK itself, let's talk a little bit about the platform. So the IntelliJ Platform is an open platform of component-driven, JVM-based cross-platform IDEs with a high-level user interface toolkit. Now, first amongst this in the platform, let's talk a little bit about what they call the project model. And so this is a single organizational unit that kind of encapsulates all aspects of a project: the project itself, all the modules within that project, the libraries your modules are using, the source code, build instructions, and how your build system ties in with the editor, and so on. Now, I will note that apparently they are deprecating this API this year for a new one called the workspace model. It's a very similar API, but aims to solve a lot of kind of aging problems with the old one, which is kind of very on point for this talk. But for now, we're just going to talk in the context of the project model, as that's what we used and cover in this talk. And it's often what you'll see referenced in most examples and references you'll see out there. So next part of the platform is the Program Structure Interface, or PSI, or SI, or however you want to pronounce it. And this is really the source of IntelliJ's true power. It's a set of functionalities used to parse files and build rich syntactic and semantic data models of your code and build indexes from this data. It powers a lot of the functionality we come to love in our editor, such as quick navigation and searching of files, types, and symbols. So whenever you Command click or Command B on a reference and it jumps right to the source code or wherever you're going, that's all powered through the PSI. Also in this, powered by this, is the code completion pop-ups, code inspections, and code refactoring, and so much more. We'll touch a little bit more on this throughout the talk, but really I could fill an entire multiple other presentations covering just this aspect of it. And next with the platform is you can also kind of go on to extend it to build out your own custom IDEs. Android Studio is is the example of doing just that, and really all other variants of their IDEs that you see. While this effort is kind of probably out of scope for you, the extensibility of this platform also lets you extend these IDEs yourself, such as in this talk where we kind of extend Android Studio. And next are plugins for the platform. So that brings us to the IntelliJ platform plugin SDK. And so plugins can be used to extend the platform in many ways. The most common of which, and what we'll focus most on this talk, is adding additional UI elements to the editor to extend its functionality for building tools right in the editor we all work in every day. So these user interface add-ons are exactly what you think. It's actions that you can add to the toolbar, menus, options you see in the menus, or changes to the inline editor itself, and various other actions. Next, after kind of these more common add-ons, is an extension point system. And so this is essentially just a way to define or implement custom interfaces that you can extend from the platform itself or from other plugins, and can be exposed and is a powerful way to kind of extend functionality. This kind of pattern behaves, or underneath the hood, is very similar to the Java service loader pattern, if you've ever used that before. And the next common way to use the SDK is to build tool integrations. So building plugins to interact with and manipulate third-party plugins or third-party tools and components directly from the IDE without switching context. The Flutter and Garrett plugins are very good examples of this. The Android SDK is kind of has good examples of functionalities of this, with how it interacts with ADB, for example. In our example, we use it to interact with our focus tooling system that I'll kind of elaborate more on later. Next, with an SDK, you can kind of create custom language support or extend support. So not only do you have the ability to tap into the existing language support, like Java or Kotlin, for example, you can extend the platform to support any language you want, or your very own language if you feel so inclined. I think the SQLite plugin is a great example of this, as it brings support for kind of its flavor of SQLite right into the editor. And lastly, you can use plugins to create your very own themes. The Dracula theme is my favorite to use, but if you ever load a custom theme into Android Studio or IntelliJ's platform, it is done through a plugin. So next, let's jump into what we'll focus mostly in this talk, which are user interface add-ons. So before we can get to, talking about extending functionality and adding on UI to the editor, let's talk about how you build UI when building out a plugin. So the UI toolkit in IntelliJ or in the IDE, almost all of the UI is built predominantly written in, with Swing, with a bit of nuance there. And if you don't know what Swing is, well, bless your heart. Swing is a multi-platform GUI toolkit for Java released by Sun and Netscape in 1997, and it has not aged a day. The IntelliJ platform includes a large number of custom Swing components that are built on top of this to kind of give it its look and feel, even with the new UI look and feel. Here you can kind of see a short example of like how that syntax flows. Obviously, so it's very simple. If you ever dig through the platform code itself, these examples get far more complex, and it's not the way I think we all want to write UI these days. Next, JetBrains built a kind of layer, a Kotlin UI DSL layer on top of this for building out forms, like those you commonly see in dialogues or settings panels. Here we get kind of like a nice, more declarative pattern for building out UIs. I think it flows a little better. And as we as Android developers move into a more composed world, this gets a little more comfortable. However, this doesn't really escape some of the swingisms of the previous example. And JetBrains generally recommends it not for general UIs like you find in tool windows and the like. Just mostly recommends for like dialogues or options or configurations or settings, that kind of stuff. And if you want, there is a UI DSL showcase dialog built right into the editor, where you can kind of show up a dialog and it shows all the examples of what you can really do with this API. Lastly, that brings us to Joule, which I affectionately call Compose for IntelliJ. So this is basically a Compose library with a desktop optimized theme and set of components for building out IDE UI with Compose. This tries to capture the IntelliJ platform's new UI look and feel. And again, as Android developers, I find working in Compose to spark the most joy for me. But I will say that this project is in very active development. I believe it's commonly targeting the latest Compose multi-platform, so your use and mileage with it may vary. So next, now that we've talked about writing UI, let's talk about how we actually add that UI to the editor. So this brings us to the first major thing you'll most commonly deal with when building out a plugin, which are actions. And actions are the basic building blocks for functionality in the IDE. And most UI you interact with in the IDE, from toolbars to menus and so on, are essentially all an action implementations. So any toolbar, combo box drop-down, selecting a different device, running a build, deploying it, all running through actions. Going into the menu, creating a new source file, creating a new package, all that's driven by actions. Interacting with some gutter icon to perform some action or trigger something, most of the time it's an action. And so here's kind of a simple example of how this looks. You implement the AnAction class and override the action performed function, and then perform whatever logic or whatever action you want to do. Each action, or this function, is handed an action event, and from this you can derive the context in which the action is performed. So you can grab the project you're working in, which is often your way into grabbing the data you typically want to work with, and then you get a lot of other contextual information, such as a file or directory that action's being executed in, the editor itself, so the editor window, if you have like executing an action in like a code file you have open, even down to the caret position in the editor that you're in. There's really a lot of things to cover there, but you can basically get the context of the editor in which you want it to execute. But actions are not just glorified runnables. They also kind of have their own life cycle and presentations. Before an action is executed by a user, or for various different reasons for the editor, an action kind of hook in for updates and then modify its icon, text, or visibility based on the context of the action being performed. And so doing this, it kind of looks like this. You then override the update function. You're again handed an event, which you can derive the context on which your action's being updated, and then kind of change its presentation or various other aspects based on the context. A common use for why you might do this is if, say you added a new menu option for generating a new code template or file. You may not want to show that to your users or developers if they're not creating something new in a source directory. Like if they're in the root of your project, you don't want to be like here generate our whole bunch of scaffolding for a screen. And it's also worth noting here is to be careful of what you perform in this update function. The editor likes to call these a lot and likes them to perform quickly. It is advised that you don't do any actual work in these functions, like reading a file or the like. They're just kind of quick ways to adjust the presentation and kind of be informed about what the editor is preparing to do with your action. So after actions, the next common way that you might add UI to the editor are tool windows. So we all know and love these, whether you're looking at the Gradle panel or looking down below at the Git or terminal or viewing your project structure in the left. These are all tool windows, which are just child windows, often with their own toolbars and thus more actions and their own UI. They can be anchored in various locations or be their own floating window. And so implementing this is pretty simple. You just override a tool window factory, override the function to create its content. The platform takes care of the window itself in positioning, and all you have to do is provide a way to add content to that window. And if you're using Joule, adding content is just as easy as, say, add compose tab, and then just feed it the compose you want to render in that window. So next, touched on this a little bit before, are extension points. And this is the third more common way to add functionality, but functionality is not as straightforward as a window or a button on a bar. And in fact, tool windows, that tool window factory I showed you before, is just an extension. Adding pages to the settings dialog is an extension. There are over 1,500 of these between the platform and third-party plugins. And if you go, which is a bit overwhelming, but if you go on their documentation site, they provide a handy browser for kind of looking through these or discovering these. I'll touch on some other examples where we use these and kind of to add UI and add functionality. And so next, now we talked about adding UI or writing UI, adding the UI to the editor. Let's talk a little bit about business logic. So how do we get data or use services to drive and power these elements? So first up is this concept in the platform called services. These are patterns very much like anything you might typically deal with, like a repository or just some kind of layer to do data stuff with. So these are just on-demand components that the platform takes care of instantiating and fetching for you. And you can use these to expose an API to other plugins that may rely on your plugin if you so wish. Or you can use them simply as an object to manage data you're trying to drive some UI element with. These can be scoped globally at the application level, at the project level, so if you open a single project or not, or at the module level. However, don't use that last one. They implied not to use it as if you work in a project that has a high number of modules. There are negative performance implications of using it. As you could imagine, whatever you might be doing might get spooled up for hundreds of instances. And then there is also this concept of light versus full services. So full service here is an example. We have an interface, we have our implementation, and then on our manifest is where you kind of wire it up, where you feed it to that. And this is a way to kind of expose like, hey, other plugins that rely on my plugin can instantiate the service. And our plugin tells the platform how to instantiate just that. And if you'll notice here in the implementation, I included 2 parameters in the constructor. And these are injected by the platform. Specifically, we're using a project scope service here, so we can get the project it's for, which gives us a lot of handy context about the project you're working in. And you can also inject a coroutine scope that's scoped to the project level. So whenever a developer closes the IDE or switches to a different project, it'll cancel the work executed in the scope. And so next, after that, let's talk about a light service. So say you need something that you don't care that other plugins can see. This is just for my project. You just create a simple class. You can inject the parameters like we did for our implementation. And then you just give it a simple @service annotation with the appropriate scoping that you want it for. And then for both of these examples, you can call project.service and give it the service type you want. And in the background, it'll take care of instantiating and only making sure that you instantiate a single instance of the service. It is recommended not to use this to capture a reference and then hold on to that. Typically, every time you want to deal with this, they just recommend going through the service accessor. So next, after services, are listeners. So IntelliJ, the platform, has basically a built-in pub/sub messaging event bus infrastructure. And I know as Android developers, we might instantly recoil when we hear the word event bus. But it's a handy way to kind of listen into various events that are fired off by the platform, by other plugins, or by ones you define yourself. Examples of this are listening to file system changes, listening to tool window operations, listening to indexing events and Gradle sync events, and like so much more. There's usually a lot. So if you're just kind of listening or just want to be a little more reactive, you'll typically do this through a listener. Next is the PSI that I touched on before. So again, this is just platform's way of like parsing the code, like your source code, and like basically generating a handy like kind of AST node type graph for you to work with. So dust off your leak code training because it's tree traversals, because it's psi elements all the way down. I'm just kidding. There are many handy tools to kind of navigate this, that it isn't just all pure tree manipulations. And some examples of this are using the visitor pattern to perform top-down navigation on your element tree, using the sci-tree util to perform bottom-up for kind of searching up the tree. You can do class inheritor search for searching for inheritors of a class that you're looking for, or it's references search to search for references of a certain object. We use this to kind of do some like DI analysis for some features I'll touch on later, or using the psi short name cache to kind of look up a class by a short name. So let's take a look at a simple example of how this really looks. Here we have this simple class that just has a package declaration, an empty class, and an annotation on it. When you look at the psi that's generated for this, you get something like this. Generally, for each element, you get like a whole top level, more simplified element that represents each part of it, such as the package directive, the class itself, and then you can see in the tree as it kind of drills down to each element. And I mean, really drills down, like really brings into the tree elements for like the com, the dot, the Reddit, the dot, the IntelliJ, and so on. And as you can imagine, as you look at more complicated source examples, this tree really grows. And a pro tip is to enable the internal mode on your in the platform properties for your edit IDE, and I'll give you access to the view size structure dialog in the tools menu that you can basically run it on any class you're looking at or paste any code into, and it'll generate this very tree you see here, as well as a handy browser for all the different elements and properties. And as you jump through this tree, it'll highlight in your source code what aspect of it is. So it's a handy way to kind of debug this as you're trying to build something to handle the PSI. And something else I'll note, like again, I could fill multiple presentations of content on this stuff. The API is not only a way to kind of read your code, it also provides a way to edit it on the fly, as it integrates with the underlying document model to make changes. So it's a handy way to kind of read, navigate, analyze, and edit your source code. So let's talk a little bit about getting started. There's a Gradle plugin and a whole bunch of stuff, but I always just recommend to go clone JetBrains' plugin template repo. It has the boilerplate set up for getting started. And it's on the latest Gradle plugin 2.0, which they released not too long ago, and sets up all the boilerplate for plugin verification, signing, and publishing. Yeah, that's the best way to get started. And then you can kind of trim it down or bulk it up as you need. So now that we've kind of covered the what and how of building plugins, let's take a look at how we've applied this for our very own plugin called the Reddit IntelliJ plugin. Very Inventive naming, I know. So first was the most natural thing, I think, for building this out, as we built out a new sub-project dialog at Reddit between our custom Gradle plugin, our internal internal structure of our code base, and modularization rules. Creating new modules or sub-projects is a very opinionated process for us. The existing built-in new module dialog simply doesn't fit, generates a whole bunch of stuff that just does not fit with our patterns and paradigms. And then we also looked at extending existing extensions for extending the new module stuff and just didn't really find that to really work for us either. I think Android Studio provides a templating system you can try to tie into, or the built-in IntelliJ new module dialog. There's like a way that it kind of lets you tie into it, but none of them really fit what we needed out of it. So we kind of built our own Joule Compose-based wizard dialog templating system, which is basically a way for us to build these dialogues in Compose, and then a way for us to easily write out how to generate what we wanted to do. And so this is powered by an action out of the new menu. So whenever they go to the root project or any submodule or wherever they might want to stick this module grouping, they then give it a name in the dialog, and based on that context, we automatically drive the path of where this gets output, the package name based on the folder structure, and then we let the developer configure various other options like optional public UI or sample apps, or GraphQL, or any of our other various features that we allow all through this handy dialog, and it'll output it for us. Now, not every new module we want to create is a sub-project or a module grouping. Sometimes we just want to do individual modules. So naturally, with this wizard we built, creating a new dialog to do single ones was a breeze. So we were able to stand this up basically in parallel. Next is naturally code templates. So at Reddit or at other teams, or like I discussed early in this presentation, is you might have opinionated ways of how you write your screens or your view models or other various patterns in your code base. So this is something that we've created kind of file templates for in the past that didn't quite fit it all the way, and various other like scripting tooling that we've written in the past that just didn't quite keep up. So we kind of wrote one where right in the editor. So instead of just going and copy and pasting previous screens or view models they worked on, we created a way for them to just generate it based on our opinionated patterns. We added most of these in a recent hack week, so this is just skimming the surface of our patterns, but it is a kind of great way to get started. The developers can just pop this dialog open, enter their name, their view model, various other configuration options that will automatically generate all that scaffolding for them, including all the boilerplate required for tests or snapshot tests or whatever else based on what we can customize the configuration for. Oh yeah, I should note that we extended Android Studio's built-in code templating system. So this is essentially just built on top of their extension. Next is we built an announcements tool window. So as our team has grown, we're at around 90 Android developers at any given moment. Whenever we make important announcements or changes about various aspects of things that affect the whole team, we try to make the announcements in our Slack channels, but as you know, Slack channels are ever so bubbling up with messages, so those can kind of fade out, and before the whole team can see them, we make announcements at our bi-weekly guilds. But being a large internationalized team, not everybody makes it to the guilds. And so these messages could kind of just get missed, and more often than not, somebody comes asking like, hey, like what's this thing, or how do I do this, or this has changed. So we thought of trying to find a way to bring these announcements directly to where our developers are, by building in this tool window that listens to a directory that we have in our project to read timestamped markdown files to present these options. And we detect when there's a new one from the last time they've seen it, and kind of prompt the window and highlight it for them here. And then next, we built this focus toolbar picker. I touched on this a little earlier. We kind of have our own set of focus script tools underneath that kind of behave very similar to Dropbox's Focus Gradle plugin, except we went with a route that didn't involve that plugin for speed and performance reasons. And so before, a developer would have to go to the terminal, run this script to say, hey, focus on this app or the sample module. I should also say a quick background is what we mean by focusing is like instead of loading all 600, 700 plus modules in the IDE and having to sync all that at once, maybe they just want to focus on a sample app or their individual feature. It'll basically analyze the module they want to target and then all the transitive dependencies needed to satisfy that module, and then just update our Gradle configuration to only load those. So whenever we sync the IDE, we'll have loaded maybe just a couple hundred instead of the full code base. And so a developer would have to go in, go into terminal, run the script, the focus. It's not you have to go to the file it generates to see what is focused on. So if you're changing tasks or contexts, you may not remember that you left focus on something, and then that's a little hazardous to be like, oh, now I got to go clear that, reset, or whatever. So we built a toolbar widget here that listens to that file on the file system and updates the widget in the bar for whatever you're focused on, whether it's a single module or a number of modules, and then added a drop-down that interfaces through a service with that script to enumerate the main targets or target groups that we allow and to present them in this drop-down. And then when the user selects one of these, it executes another action to basically call that interface through our service to tell the focus script to re-update or clear or whatever. This is probably our most integrated feature between everything I've talked about. Next, we wanted to enhance our experimentation interface, or specifically working with our experimentation framework. So what we did was basically use a reference contributor that allows you to kind of provide custom language references to your code. This is the mechanism by which, when you're building like language support, so for like Kotlin or et cetera, when you go to a class and command click it, or whatever jumps you to a file, it's basically a reference. It's like these links around in the code. And so what you can do here is go in here, use it to analyze the PSIs and say, hey, I'm looking for this string literal that's in a certain class and has a certain annotation in our instance, experiment cleanup information that we use to track these, and just be like, hey, add this URL reference for it. And then we generate the hyperlink to the web UI for our experimentation management. So instead of having to find this, copy this, go to the web UI, search for it, then click it, and then you're at your experiment, the developer just has to go here and command click it, and it jumps them right to it. And I didn't touch on this, but we did the same thing for Jira tickets. So we do the same kind of idea. We regex for Jira ticket formats. So any Jira ticket in a comment or string literal in both Gradle and Kotlin will hyperlink out to Jira. So no more copy and pasting or mix of developers pasting in full Jira links. We now make it easy to jump around. Additional to the experiment, we also added a line marker provider. And so this is just a way for you to provide gutter icons to whatever code, or basically attach it to any leaf element in the side tree. So we did the same thing here where we detected our experiment string. We added an icon here that allows you to instantly deploy that experiment, whether the controlled or enabled variant, or if it's a multivariant, directly to any device connected over ADB. Obviously a debug, and then we have a receiver on our device that we already use for some of our end-to-end testing suites. So this just interfaces with the ADB tooling out of Android Studio, which is like their own service. And so you can kind of change experiments right on the fly. This has been handy. This has been handy as like whenever we work on call as part of platform, if we're chasing down bugs through kill switches, it's nice to be able to flip that rather than having to dig through developer settings menus to change this to verify. Next, when we rolled out sample apps at Reddit, we use Anvil, and in part due to legacy modularization or poor modularization, sample apps, which kind of host their own kind of like mimicked image or scaffolding of our application's DI, and due to stuff on the class path, it would erroneously kind of over-merge things from other features to the various reasons. And so this makes it difficult for developers to kind of bootstrap new sample apps or configure their DI, or if they ever make changes and it's like, oh, we're missing a bound instance for something that seems wildly unrelated. And it's like, it shouldn't be in there, but for various reasons, it gets pulled in there. So we created a simple action here that basically does a whole bunch of psyops to where we kind of statically analyze the DI graph that's needed for that feature, and then automatically generate, say, like a user component that excludes everything that's getting contributed that we don't want it to. And then it attempts to be idempotent, and so you can rerun it to kind of refresh that as needed as you're editing. This has alleviated a lot of headache, and bootstrapping this is not perfect. But was something that we did with the plugin. And next is, as we talked about on Anvil, and I spoke about this at DroidCon last year, before we migrated fully over to Anvil last year in 2023, we had over 350-ish screens on a legacy pattern and a handful of screens on a pattern that predated that one. And so, as you can imagine, when you introduce this, it's hard to get teams to migrate their screens. We were able to capture greenfield work and new features, but it's daunting to ask teams who, may already struggle with understanding DI. It's a difficult concept if it's not something you're working within actively, and difficult. So we built an extension or an intention action. So like, if you hit Alt Enter on the class and it says to generate a test for that class, that's an intention. So we built a custom one for migrating it. And so when this is executed, we analyze the class it's executed on. We find the handwritten legacy Dagger component that was written for it. We find where it's used and injected in the class, and then reference upstream where it's wired about. So then using the Psi APIs, we delete the old reference, delete where it's injected in the class, analyze the old written subcomponent to generate this new inject with annotation, and everything it needed to basically mimic the functionality, add that to the class, delete the old subcomponent, and add the new injection code. And for about 99% of our use cases, this worked. And so all you had to do was run one action, and the whole screen would get migrated like that. And so that helped us over the course of the year to completely migrate over to this. And so kind of wrapping up, that's all the features we have in our plugin so far. But this platform, we're leveraging this platform is very extensive, and there's so many things you can do with it. And so we have a running list that we're in docs of a lot of features we want, and a lot of our team members have started to contribute kind of a wish list of stuff they'd like to see or things that might help them perform their job better. And so some of these are deeper experimentation integrations. So we just did kind of some nice stuff on top of our current interface layer, but it'd be nice to add maybe a dialog that can just generate all the boilerplate for adding new experiments or kill switches for gates. Maybe take it even further using the PSI APIs to, hey, like I want to clean this one up, and analyzing through all the trees for that gating and editing them for you. More templates for our opinionated patterns. We have only kind of touched the surface on those, but there's a lot more I would like to do to kind of reinforce these and make them easy for developers to do. I think there was I can't remember who wrote it now, but there's another great talk about using a plugin to do module scoring and gamification as a way to kind of keep track of where your tech debt is in your modules and kind of giving it a score. Doing stuff for generating, just like we generate Reddit-shaped code, generating Reddit-shaped tests, and giving the same kind of treatment to our tests and generating test and test code. Making composite builds easier. We have kind of a limited set of composite build setup already, but these are kind of kludgy to work with and are powered by scripts that not everybody really knows about. And if you're not familiar with composite builds, it's kind of a way to pull in another project or repository into the editor and have it kind of supplant your typical dependency definition in the repository. A good example of this is when we're working on our custom Gradle plugin. Or really any third-party library that we're kind of testing changes in. It's really difficult to go and make your change, publish the admin local, force a consumption, and that cycle is so slow. So, it would be nice to kind of use this tooling to build something that can make it easy, such as just, hey, go pull in this folder, or like, here's a Git URL, bring it in as a composite, and so on. Additional DI graph visualizations. Like I said, working with DI is a complex problem, and it'd be nice to build some tools to give developers better contextual information about the components and stuff they're working on in the editor. So I'm not getting DM'd all the time about like, hey, which scope does this go in? And then of course is probably my most ambitious idea, which is dynamic sample apps. And so I talked a little bit about the tool we built to solve that. I'd like to take it a step further, and instead of managing 40 some odd sample apps or more, that list kind of comes and goes in our repositories, and there's various maintenance burdens with maintaining individual ones that you can imagine, and just being able to use the PSI to analyze and generate these on the fly for our developers. I think there was a great presentation not too long ago from an engineer at Airbnb who kind of showed off a similar concept I think they do that looked really cool. And so we've had it deployed for a little bit now, and I've gotten a lot of great feedback from our team. They've really been enjoying these nice quality of life stuff, and have been excited about stuff that they could do or stuff that really impacts their realm and can make more mundane tasks a little easier. And that's basically the end of it. I'll have some resources here, again, to get you started. First is the official documentation. They have a repo for code samples. The IntelliJ IDE and Android Studio are both open source. So the most common way if you're trying to figure out how to do something is look for somewhere in the editor that's already doing it or similar, and then go finding it in the source code and seeing how they actually accomplish that. And then another page is the template, of course. Joul's in its own repo. They have a great set of samples for how to use the various components and elements. Slack's Skate plugin is open source. That was a great jumping point for me. It's another great example of how to do some of this stuff. I will also plug, I didn't put it here, but Flutter's and SQLDelights plugins are also open source. Those are also great references. And of course, there's a IntelliJ icon explorer. So when you're looking for nice little flashy gutter icons to use all over the API, they have a brilliant, just like Google has for their material icons, they have a nice one for all the platform icons. And that's it.